Hi, and welcome to this clip looking at a radical substitution and formula determination of a substituted alkane exam question. So it tells you under suitable conditions, butane C4H10 reacts with chlorine by radical substitution, and a mixture of organic compounds is formed, including C4H9Cl. So obviously this is a mono-substituted product, which you need to keep an eye on, making sure that that's what you put when you do your mechanism. So there's only the initiation and propagation are required, not the termination. And they want you to use molecular formulae, which is quite handy because it avoids having to work out where on the carbon chain substitution has occurred. So you're reacting with chlorine, so you need to start by making chlorine radicals using UV light. Then one of the chlorine radicals reacts with a butane molecule to make a butyl radical, C4H9, with a dot next to the carbon. The carbon is the atom that's going to carry the unpaired electrons, so the dot needs to go there, not on the right hand side. And you also get an HCl molecule. The second propagation step is when the butyl radical goes and attacks another chlorine, and you get C4H9Cl plus Cl dot. The next part of the question is asking you to write the equation for the formation of compound D from butane. Now, because you've substituted all of the H atoms in butane by chlorine, you can imagine that every single hydrogen that I'm highlighting is actually being swapped for a chlorine. So that allows you to come up with C4H10 plus Cl2, giving you C4Cl10. And the important thing to remember is HCl is the side product, not hydrogen. So what you've got to do is think about the balancing number for chlorine and for hydrogen. Hydrogen chloride, I meant to say. So therefore you'll need enough chlorine atoms to provide 10 Cl and 10 HCl. So in other words, you need to have enough chlorine molecules over here to provide 10 chlorine atoms here and 10 HCl's. So moving those over to make some space, you end up needing to put a 10 in front of the Cl2 and a 10 in front of the HCl. So this is a more applied section of the question, and this is because when it mentions the substitution, it only says that some of the H atoms in butane are substituted by chlorine. So we don't have an exact number to work from, but we need to work out a molecular formula. So we start with the information we're given. We're given a volume in centimeters cubed and a molar gas volume that isn't the same as what we're used to. So we're used to it being 24.0 decimeters cubed per mole. So it's easy to get around this problem. Instead of V equals 24,000 N, which you'd use because it's in centimeters cubed, use V equals 32,500 N. So inserting those numbers in and then rearranging so that the number of moles of compound E is the subject, you get 0.0024 moles. So using moles equals mass over molar mass, and we insert the values in that we have, we come up with 265 grams per mole. So the problem solving part is finding the formula. So our formula is obviously going to have 4 carbons in it because butane has 4 carbons. So we start there and that gives us 48. Take that away from 265 and we get 217. The next thing to work out is how many chlorines will fit into that. So you divide 217 by 35.5 and you get a long number, 6.11. I put dot dot to show you the truncated version here. Now obviously you can't have 6.11 chlorine atoms, so we're going to go with 6 chlorine atoms. So 6 chlorine atoms gives you 213. So that means you've got a little bit of space left to put in hydrogens. So the formula must be C4H4Cl6. Okay, thanks for listening. Until next time, see you soon.